Hi everyone, and welcome to today's Physics Daily Booster. This is number 13 in our Paper 2 series, and it is on the advanced information list for those of you doing foundation physics. While not explicitly listed on the higher tier physics, that doesn't mean there won't be questions on it. So still worth having a bit of a recap just in case there are a few marks that you get from this topic. What we're going to do is have a look at the 8.2 section of the specification today. So this is looking at basically generating electricity. Hopefully we remember that when we talk about energy sources, this is something that we can use for either heating, transportation or generating electricity. And our energy sources fall into one of two categories. We have renewable energy sources or non-renewable energy sources. If we're asked what does renewable mean, that means it will not run out. Please don't use other random phrases. Will not run out is what you want to say here. If we talk non-renewable, it's the opposite. These will run out. And the reason for that is that we are using them at a faster rate than they are being made. Now, in the bottom corner here, we've got our different energy sources. So renewable first of all, biofuels, sun, tides, wind, waves, geothermal and hydroelectric. Non-renewable, nuclear and fossil fuels. And hopefully we remember that our fossil fuels are coal, oil and our natural gas. So it's possibly easier to remember fossil fuels and nuclear fuels are non-renewable, everything else is renewable. So that's an easy way to remember it, but learn just two examples, I would say, of renewable, two examples of non-renewable, and you should be absolutely fine. But do know that the three fossil fuels are coal, oil and gas. In terms of what we use those energy sources for, as we've mentioned, we use it for heating. Now, examples of heating tends to be fossil fuel, so most people probably have a gas boiler in their homes. If you're slightly more rural, then you may have an oil boiler instead. Very few people are going to be burning coal in their homes anymore. Although this year, who knows, we might all revert to coal burning. We also use biofuels, so think about wood in that case, that works, and a range of other biofuels there. And then the sun and geothermal if you live in the right place of the world for that. Transportation wise, back to fossil fuels again, so crude oil, that is going to be used to separate out into our petrol and diesel, and biofuels, so we have things like bioethanol for example. And then finally generating electricity. The UK, we still are quite reliant on fossil fuels in order to generate our electricity, but we are increasing the number of renewables we use these days. Now, that's not the only way that we can actually heat our houses by burning stuff, basically. We can do some rather clever designs in our homes. So if we think about it before we even start building a property, we can use ones that have things like south-facing windows, because that means because the sun is always going to be shining on that part of the house, we will then have this passive heating effect. We could use solar panels, something that an awful lot of people are looking at the moment, I would get. And then we can also, in some areas of the world, use hot water from underground. So that's the geothermal idea. And there are some countries where they've got a lot of these very hot rocks underground that we can use to heat water, that heat large proportions of their area using that hot water from underground. Other ways we can generate electricity, then we can have solar cells, those photovoltaic cells. Again, lots of people look at investing in those and whacking them on roofs at the moment. We could then look at wind turbines as well. Waves, geothermal, hydroelectric, biofuels, all of those allow us to generate electricity without burning fossil fuels. So this is most definitely an area that we are looking at very closely at the moment based on the prices of things like the natural gas that's rocketing at the moment. One of the key things that hopefully we know is that as time has gone on, then there's been a change in the demand for the energy sources, and the main reason for that is that we've seen an increase in population. The more people there are, the more homes we have to heat, the more the electricity demand increases, etc. So the higher the population, the greater our use of different energy sources because of the demands of the population as a whole. The problem we've got, where we are still very reliant on fossil fuels, is that they are finite. That means there is a limited amount of them in the world, so they are going to run out. And what we find is that a number of our reserves of fossil fuels that still exist are actually in regions of the world that are pretty tricky to get to and to extract the fossil fuels from. So that means it's more expensive to get hold of them in the first place. The more expensive it is to get hold of those fossil fuels, the more we have to pay for it when it gets to our homes as well. So we see that side of the problem. Another problem is obviously burning fossil fuels produces carbon dioxide. Now, carbon dioxide is a greenhouse gas, which means its accumulation in our atmosphere is going to lead to climate change as a result of the enhanced greenhouse effect. So again, something that we are hopefully all very aware of from everyday life, and why that is a bad thing that we want to avoid as much as possible. Just in case any of you have been living under a rock for the past few years and have no clue about problems of climate change, here's a little list for us. The ice caps are melting, and they are melting at a rather scary rate. Because the ice caps are melting, then that means our sea levels are rising, and as a result of that sea level rise, we are seeing more coastal flooding. So make sure you know at least two of those answers. In addition to this, we are seeing more extreme weather events. So that means that we are having stronger hurricanes, more tropical storms, and we're seeing greater periods of drought. We're seeing forest fires and all of these things becoming more common and more severe as a result of climate change. Because we're seeing things like these droughts, etc., and floods in different areas of the world, then what we're getting are threats to our food supplies. So a good example of where this is a big problem is in America at the moment. If you look at the news, you'll be able to see stories on this, where one of their large reservoirs is Lake Mead. Now, Lake Mead is a massive reservoir found in Nevada, I think it is, that basically supplies the agricultural land in California with its water. At the moment, Lake Mead is very much drying up to a scary point that all the bodies that the mob dumped in there over the years thinking no one was going to find them, then they're turning up. So you can have a little look at bodies in barrels if you really want to, if you do a quick Google for Lake Mead and bodies. Now, obviously, the greater concern there is less about the mob finding the bodies, but more about the fact we are not able to produce the water needed to actually grow the crops needed to support the population. And this isn't just in America, this is across a number of countries that we're seeing these threats. So, obviously, this is a bad thing. We want to avoid climate change as much as possible. But it's not simply a case of governments just turning around today and saying, you know what, we're not burning any more fossil fuels, job done, it's over, no more fossil fuels from this day forward. Because we need to still produce electricity, we still need to be able to get around. So we've got to have something we can swap over to. And in order to actually find a different energy source, we've got a few things to consider at a government level. How much does it cost? What is that environmental impact? And how long will these new sources last? Because it's all good and fine saying we're going to swap over to source X, but if that's going to run out in 10 years, probably not worth it. So we need to think about those three things to see if it is worth it or not. So once we've generated our electricity in a power station, what we need to do is transport it around the country. And the way we do that is through this thing called the national grid, which is literally a system of cables, power stations, transformers and substations that allow us to move everything from the power station to our homes at the other end. Key parts here are going to be our transformers. We have step up that increase the voltage and step down that decrease the voltage. And that's going to be really important in efficient transmission of electricity across the country. When we are talking about these transformers, they are going to change the voltage or the potential difference with the main purpose of reducing the heating effect in the wires it's travelling through. So we've got the step-up transformers that are going to increase the potential difference or increase the voltage, and the way that they work is having more turns on the secondary coil than the primary coil. That means that we have a much higher potential difference and therefore a lower heating effect on the wires. However, we do not want something at several 100,000 volts entering our homes. That would be pretty risky in the grand scheme of things. So we then need step-down transformers to decrease the potential difference or voltage at the other end, and they have more turns on the primary coil than the secondary coil. So this is a bit of a link back to the work that we did in P4 on transformers. So paper 1 and paper 2, bit of an overlap here. Now, the reason we don't want the wires to heat up is because we are then transferring energy from, obviously, our intended store to the thermal store of the wires and then the thermal store of the surroundings. We will see that dissipation effect, i.e. we are going to end up wasting energy. Now, if we waste energy, that means we've got to burn more fossil fuels in the power stations to then generate the amount of electricity we need for all our homes and businesses to work, because a proportion of that didn't make it. It was transferred to the thermal stores instead. So the amount of heating that we get in those wires is dependent on two things: current and resistance. So by increasing our potential difference, what we're actually doing is reducing the current there. What we find then is when we are inducing this current in wires, we get that heating effect. So as we've said, that transfers energy to thermal store of the surroundings, obviously as it dissipates from the wire itself. If the wires have a higher resistance, then we're going to get more heating. Just like if we have a larger current, we get more heating. So if we can reduce the current or reduce the resistance, then we are going to reduce that heating effect and therefore have a more efficient transfer. Don't be surprised if they give you a little calculation to do with efficiency in here. So obviously just remember standard efficiency, change it to a percentage by times it by 100% at the end. If there are bits from today's booster that you'd like to go through in more detail, then you can look at the P8 playlist on the channel, your revision guides, and of course have a look at some of the past exam papers to get a feel for the kind of questions that come up on this. Then don't forget to join us again tomorrow for our next Physics Daily Booster.